Okay, using Hyper-Parity to find domino corner skeletons for DR scrambles from QQNet. So here's the scramble. What do I have here? My UD stickers are 2 away from solved, and my FB stickers are 2 away from solved. So this looks like a good corner case. So that's here. That's the one that's just 2, 2 if parity is even. 1, 2, 3, 4, 5, 6, and then those are so 6. That's odd parity. So these corners with odd parity is actually the worst. Is actually the worst case because you need 5. You need 5 quarter turns to solve. It's going to be something like 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, or 1, 2, 3, or 1, 2, 1, 2, 3, 4, 5. There are lots of possibilities, and they're all like, and it's probably going to be like 12 moves to solve. This is a case I would just skip. I wouldn't even bother to do this. All right, so let's say we've scratched that one. We're moving on. I'm just going to look at another scramble. So just to say, what's the likelihood of a case like that? So the only ones I actually skip are the ones that require 5 quarter moves. There are only 4 cases, 4 out of 34. That's if this is this or this or this or this with odd parity needs 5 quarter turns, and so that's 4 out of 34. So basically, I'm considering I'm throwing out the worst 10% and looking at everything else. So let's look at this one. This one has UD corners are solved, and FP corners are 1 turn away. Right, and the way so remember, there's a good and a bad here. The way I know if it's good and bad is if I try to solve the FB corners. Can I preserve the solved state of the UD? I cannot. So this is in the quote-unquote bad. And let's look at parity. So 1, 2, 3, 4 plus 1, 2, 4 plus 2. That's even parity. So even parity is this not so bad with this one because you can just do that, and that's the only even parity state. With 2, you could actually do some with 4, and then maybe I'll look at those. But let's do this one first. So this one is it's just an F2 U, and then I bring bring these together. So that's going to be U, B2, U2, R2. Am I flipping any pairs? No. B2, U2, R2, U prime, R2, okay, R2, F2, R2, U prime, F2, R2. So that's 1, 2, 3E plus 2E. 1, 2, 3, 4, 5, 6, 7, 8. 8, 2, 3E, 2E. Ignoring the E6. Okay, so here I am again. So what options do I have for 4? I can do 1, 2, 3, 4. I can do something like 1, 2, but that's basically the same as inserting an edge commutator, because if I go back to the same spot, I haven't actually changed my path. I've just kind of done like a one of these edge commutators. So the only one that's actually substantially different is the one that goes like this: 1, 2, 3, 4. So let me just look at that one just for grins. So that's this one. 1, 2, 3, 4. So that starts by actually solving the UD corners. That's going to be R2, U2, F2. U, and then this needs another R2, U2, F2, R2, U2, F2. I'm not too careful about my U prime, B2, U, and this doesn't look that promising. Let's go B2, U2, L2, U. So that's a long 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, forget that. 1, 2, 3, 4, 5, 6 to 6E. So that's not promising. Let's look at the inverse. Okay, here's the inverse. My UD corners are solved, and I'm 1, and so I'm actually in the same state. So I think I'm just going to look at this one. That one looks like B2 to preserve that pair. U. I'm going to do U prime, so I can form that 2 by 2. R2. I'm going to do D2, F2. R2, D2, F2. D prime, F2, L2. And what do I have? 1, 2, 1, 2, 2E, 3E, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. For these short versus sometimes not really worth it. But yeah, looks about the same. So this looks like it will. I usually count like one extra. Usually count one extra move for each edge. So I would expect this to yield a 13. Let's see what Nissi says. Okay, so here's what Nissi found. Nissi found a 13 mover. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. And if we look at what it looks like, it's an R2, B2. So yeah, it's doing this. D prime, F2, D2, F2. That didn't change us. And then U. So we're actually going here. U, R2, L2, U, R2, L2, D prime. But like I said, that's like inserting an edge commutator. I don't consider that an extra path. Just U, R2, L2, D2. That's like a slice insertion. And then yeah, so then L2, D prime, D2. So this is findable from this skeleton. This is like a F2, D2, F2. So that's like one of these. That would be an insertion like this. That would be like a slice insertion. Yeah, so that's how you find it from this corner skeleton.